This is IAT 806 Lecture 12.2, continuing on our discussion of hash tables, and now what we're going to do is focus on the Java collections. Okay, so that is kind of wraps it up for us talking about data structures, and we've seen searching and sorting algorithms. This is, kind of like, the thumbnail sketch of the kind of thing that you would learn in a computer science course or a sequence of courses that are about, the techniques of how to deal with data storage and algorithms for dealing with stored data. I've given a really, really brief set here, kind of like the top 10, mainly so you can get an idea of what the techniques are. I've been saying also, what happens if you want to, kind of implied throughout this discussion and in the previous one that you should be writing these the code to do this, but that's not necessary when you're using Java. In fact, there is this suite of software called the Java collections, which embodies these techniques and does them right because they're intended to be used by everybody who writes code in Java. So a Java collection class is a class that stores and organizes data. It uses one of the algorithms that mentioned in the previous lectures, binary search tree, linked list, hash table, etc. So the Java collection framework is a unified architecture for representing and manipulating collections. And it consists of, this is a Java technical term, so just accept it for the time being, interfaces, which are the means by which you access a collection class. That's not user interface. This is a Java term that means essentially something that's just like a class without any underlying implementation whose job it is to specify, here's how you access this facility. Somebody else has written all the details for it. It also consists of implementations. That is to say, the implementations of hash table, the implementations of binary search tree, and so on. So the machinery behind the interface that does the work. Remember the Java interface that I'm speaking of, not the user interface for Java programs. It also contains algorithms. So I mentioned sort the other day and search. Those two functions, two or three functions with the special comparator object, those things are part of this Java collections framework thing. And the whole point of this is that it's essentially a very nicely packaged way of getting access to these, classic techniques that work really, really well and are really efficient without you having to sweat how those details work. The Java people have done all that, and you get to use the technology. Now, the Java people have done a bunch of things for you. This is kind of like a level above, sort of straightforward programming languages. And we use this kind of stuff all the time. Think of the graphics package. That's just a suite of techniques that, we're just going ahead and using without having to write them up. So why do we want to use these things? Well, first, it reduces programming effort. You don't have to write binary search tree. You can just use theirs. And of course, doing this increases program speed and quality. And it's the quality thing that really matters to us. Speed's important, but really the most important thing is for it to work right and for it to not be broken. I occasionally found myself writing binary search trees and, I spend some time screwing it up. That's not what you want. You want it to be, just the correct version handed to you. The other thing that's really important is it's interoperable. You and I can pass data to each other. My code can give data to your code and say, this is in an array list and that thing is in a hash table, and you know how to deal with it. You know how to get data out of my data structure, and that can be really convenient. We don't have to sit there and plan out how to exchange, in my piece of software, how to exchange data with your piece of software. We just use this standard piece of software like, hash table or whatever it is, and it does it. We know what to do because we're both using the same suite of techniques. So here are the set of interfaces. At the top, and this is kind of like this is a class diagram. At the top is this general notion of collection. And you think these subclasses, if you will, are things like set, list, queue, and sorted set. And we'll talk in slightly more detail next, is map and sorted map. So list, we've seen one of these before. Array list is a member of this thing. So a collection is a group of objects or elements. This is a generic idea. The more detailed collection types are the ones you actually use. So what's a set? A set is a collection with no duplicate elements. Okay? So that's from set theory in the mathematics. From mathematics, it's an implementation of the same concept. A sorted set is, just right here. A sorted set is a set that has no duplicate elements that is also in ascending order, typically alphabetical or numerical order. Okay? And using the technology that we spoke of the other day, where the thing that's in the set, you have you write a piece of code that fits in the comparator specification, and it can, sort your set of whatever it is you've got. A list is an ordered collection that may contain duplicates and can be accessed by index. So array list is a list. So we've already been using this stuff. Now we're just talking about, kind of the wider world of where this lives, so to speak. A queue is a collection that holds items in some order, typically FIFO, or first in, first out. The other is LIFO, last in, first out. So a queue is the first person to arrive is the first person to get service. And, people line up behind those people. We've all been queuing a lot these days, and separated by 6 feet. Anyway, a queue is a collection of items that holds things in some order, typically order of arrival. A map, this is where things get really interesting and valuable, is a collection that maps keys to values. So this thing about hash tables, I had key and value earlier on, right? Hold on 1 second. So I just quickly scrolled back to slide 6, just basically say, here's the key, the stock number, the key, the stock number, and the entry or the value, the stuff that the stock refers to, apples, and maybe the number of apples that are, in the store, and, its price and all that kind of good stuff. We're just showing the stock number and the name in order to keep it brief. But that's what we're doing when we're saying key, the index ID, the little sticker that has, a 4-digit code on, your apples and oranges, and the rest of the data, which is all the information about, the thing in the grocery store or whatever it is. So getting back to slide 15 again, a map is a collection that maps keys to values. The language is perhaps a little funny there, mapping key to value. That is to say, I got the index, the stock number, and I need to get the thing I care about, which is the name, the price, and all that good stuff. A map may contain duplicates. It can access by index. A sorted map is a map that is in sorted order of keys. Okay? All right. Now comes the fun stuff. Well, maybe not that fun. So, how do we use a list? Well, this is a repeat from before without the type specification. So array list A list equals new array list, giving a hint that its size is 6, some class item, new item, existing item, item equals some class, class is the name of the class, and there are these 3 instances. I can get item I out of that list, cast it to some class, and stick it in item. I can add it to the list. I can remove it from the list. Okay? So, all this is doing is just giving examples of use. It's not necessarily coherent code to actually do something. So, here's the class, named SomeClass, and there are 3 variables that are of type SomeClass. And if we were to retrieve this item, we just say alist.get, making sure to cast it to some class type. If we want to add items to the A list, we just say alist.add of the new item. If we want to remove an item from A list, and let's say the existing item is the thing we want to get rid of, we just pass that, and behind the scenes, the array list gets rid of it. Okay, now let's use a hash map. So a little bit more code here. So we declare a type hash map, just like we said array list before. We're going to call it HM hash map equals new hash map. Now, what we're going to do is we're going to add entries to the hash map. So instead of just add with one parameter, we use put. Has the same idea as add, and that says put this thing into the hash map. And this is the key. I'm using literals here, Ava, and the value, the stuff we care about. We're just giving it a string, the phone number. And so all this thing is a map from names to phone numbers. I look up the name, I get the phone number. Okay, so we put in Mary and Joe and these 555 numbers. And then now what I want to do is I want to get, I've put stuff in, now I want to get stuff out. So string phone, these are strings, right? So I want to get the phone number of somebody. I want to get this Mary's phone number. So I say hm.get Mary. And behind the scenes, it hashes Mary, finds where that table entry is, and gets it. It discovers Mary is there, and so it returns to me Mary's phone number, which is the string that we just put in here, this 5551238 thing. hm.get, just like ArrayList.get, if you didn't specify the type in the angle brackets, is an object, so we cast it to string here. Now let's show how to iterate through this list, through the hash map. While I.hasNext, right? So sorry, I jumped ahead too fast. So there is a special type called iterator whose job it is to kind of keep its finger on where you're at in the data structure. And every time you say, give me the next one, it moves its finger along to the next item. And it has a special value that says, I'm empty now. So iterator I, right? We're using capital I just to distinguish from our usual I variable for an index, equals hm, this hash map, dot entry set dot iterator. And what that does is it gives us a little piece of data and code whose job it is to say, where am I in hash map? So it starts at the starting position of the hash map, whatever that means. So now I can use iterator as an object whose job it is to go through the hash map it is associated with. So while I.hasNext, so that is a single method that returns true if there's something next in the hash map in this case, and it returns false if it's at the end, that there's no more stuff for the iterator to iterate through. If that's true, then I want to get the data that is the entry. So map.entry me equals map.entry.i.next. So what the next thing does is it returns the next item in the hash map in this case. So give me the next thing, whatever it is. And then I can say print me.getKey and get value. So basically the entry is the key and the value together is this kind of composite of that pair of things. Okay. So what we're doing is showing a little bit of technology for iteration. You'll notice that this is a while loop, but instead of having an index variable that is a number, what we do is we have these two things built around the iterator. The iterator is this thing that's holding the state of where it is in the hash table in this case, and it stores where it is so that it can be revisited again and again. And the point is that the storage is inside this iterator, and all the details of what is going on in the iterator are up to the iterator. We ourselves, as programmers of this thing, don't care how that stuff works. We just know that it does work. Now let me blow your mind. Now let's do it with a tree map. So I changed the previous code from hash map to tree map. Hash map, tree map. So what's a tree map? Well, a tree map is underneath the covers a binary search tree that does this mapping function. You got a key, you got a value. So a tree map underneath the covers is a tree, a hash map underneath the covers is a hash table. but you notice that tree map and hash map are used identically. So I say tree map TM instead of HM. I put Ava, Mary, and Joe and their phone number. I got Mary. I then iterated. The code's the same, which is the real bonus. So there's hash map, there's tree map, there's hash map, there's tree map. The only thing that's changing, I changed the highlight from in this ME stops being highlighted on the tree map version. And the only thing that's different is TM here and HM here. That's it. That's the only difference. And it didn't even need to be TM versus HM. I could just have the thing be M. You know, hash map M equals new hash map, M dot put whatever. And if I decided, you know what, I don't want to use a hash table no more, I want to use a tree, I just change the type and Bob's your uncle, I'm good. And my point is that this is the real bonus of using these Java collections, is that you can decide, I just want the different, I want the tree implementation because I'm going to be doing things differently than the hash table thing. I'm using a hash table because I thought my table was going to be very stable and I'm going to do a lot of searching, but no, it turns out I'm going to be adding stuff in, throwing stuff out of the, the structure all the time. And so tree map is a better thing to use. Typically, a lot of time people have their favorite and they always use the favorite. One of my students a while ago always used hash map for everything, and I pointed out to him, hey, you recognize it's a hash table under there, right? And go, oh yeah. And he was, everybody gets to learn a little something as you continue to work on writing programs, and that was something he learned of, choose a representation that really suits the problem that you have. And so that's the real lesson of this thing. Not only how can you use this, very nice functionality that is customized to the kind of problem domain that you've got, but also what's the the right tool for the job. Should I use a hammer or a screwdriver? Well, they're both hand tools, but one thing's built for a particular kind of purpose. You can use a screwdriver as a hammer, but that's kind of lame. But that doesn't mean that it's illegal. It's not like the tool police are going to come and get you if you start pounding nails with your screwdriver. It's just that you're going to hurt yourself eventually when you miss and you pound the nail with the handle of the screwdriver and it slips and you bang your hand on the whapping. And it's the same, hash map versus tree map. There's going to be a performance difference depending on what you're doing with it. And, you should be judicious. Alrighty, so that concludes IAT806 lecture 12.2, where we've talked about the Java collections classes. Enjoy.